Hello students, welcome to my channel All Rounder Science Tutorial. Today I have to discuss about the chapter measurements class 9 physics, and these chapters we have to calculate how to measure the substance, if it is the smallest or some things, and also the volumes calculations. So let's take a video. If it will like to you, please subscribe my video and like. Let's do. First of all, chapter name is a measurement. Measurement means the measure of a substance. If our measurements, we first of all take some units, that is a centimeter, millimeter, centimeter, millimeter. Millimeter is the smallest units in the metric system. We know that after kilometer, hectometer, decameter, meter, decimeter, centimeter, and then millimeter. So this chapter is main two things is Vernier calipers and the screw gauge. So Vernier caliper, we have first draw the Vernier calipers like these diagrams. We simplify the Vernier calipers. By freehand drawing. So this is a Vernier caliper. Vernier caliper or caliper scale. So Vernier caliper have a Vernier scale, and this is a main scale. Main scale means normal scales, and the main scales, obviously we know that main scale, that is a 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and that is 10. So main scale have a 10 divisions. Sorry, 10 divisions. So 10 divisions in the main scales, and the Vernier scales, and that is a 0, then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's 10. The Vernier scales have also 10 divisions. So main scale 10 division equals to 1 centimeter. Main scale 10 division equals to 1 centimeter. 1 centimeter means 10 millimeter. So smallest measurement accurately by main scale, that is the using scale in our geometry box. So smallest measurements accurately by main scale is 0.1 millimeter. How it is 0.1 millimeter? Because there is a 10 divisions. 10 divisions equals to 1 centimeter. 1 division equals to 1 by 10 centimeter. Sorry, this is not a millimeter. 1 by 10 centimeter. So 0.1 centimeter. So accurately measure 0.1 centimeter. Main scale can accurately measure 0.1 centimeter. Each divisions is 0.1, 0.1, and then you have to go that 10 divisions, and that is a 10, 0.1 into 10, 0.1 into 10, we get 1 centimeter. So now, main scale can measure accurately 0.1 centimeter for each gradations. Vernier scale 10 division coincides. Main is the coinciding factor of the Vernier scale. Let's take an object in two jaws of the Vernier caliper and then measure the diameter of this object. Vernier scale, Vernier scale 10 divisions coincides with 9 divisions of main scale. 9 division of main scale. One division, that is 1 division, equals to 9 by 10 divisions of main scale. So 10 division coincides with the 9 divisions of the main scales. So Vernier have 10 divisions that coincide with the 9 divisions of the main scales. We take 0.9 because 9 by 10 is a 0.9. Value of one main scale divisions. Value of one main scale divisions equals to 0.1 centimeter. Value of one main scale division is 0.1 centimeter. Sorry. So I rub these sentences to clear your views. Value of one main scale division is 0.1 centimeter. The least count is value of one main scale divisions divided by number of divisions of Vernier scale. Value of one main scale division, that is a 0.1, and number of division of Vernier scale, that is a 10. So after calculation we get 0.01 centimeter. Sorry, 0.01 centimeter. The main thing is the Vernier scale is there. Vernier scales have 10 divisions and the main scale, each gradations have a 10 divisions. So Vernier scale 10 divisions coincide with the main scale 9 divisions. Rather than we can also write this is a formula. I have to give the formulas to how to measurements the Vernier scales. Rather than we can also write n divisions of Vernier equals to n minus 1 divisions of main scale. N division of the Vernier equals to n minus 1 division on main scale. Let's take one main scale divisions. One main scale division equals to x. Let's take one main scale division x. For Vernier, n minus 1 into x. How it is possible? So n division of the Vernier scale, we know that the 10 division of the Vernier scale is the 10 minus 1 9 division of the main scale. So n division of the Vernier equals to n minus 1 division of the main scale. One main scale division, if it is x, for Vernier, n minus 1 into x. For one divisions on Vernier, that is n minus 1 x divided by n. Okay. So n is the number of division. N stands for the number of divisions. So for one division on Vernier, one division is n minus 1 x divided by n. So least count, then we have to calculate the least count. First of all, the n division of the Vernier, n minus 1 division of the main scale. One main scale division equals to x. So for Vernier, n minus 1 into x. For one division on the Vernier, n minus 1 x divided by n. Now the least count. First of all, we takes the values of the least count. It is the smallest. It is the smallest measurement that can be taken accurately. It is the smallest measurement that can be taken accurately with it. The smallest measurement is the least count. So least count by calculation here, one main scale divisions minus one division on Vernier scale. Let's go. One main scale divisions, we know that we have to take in one main scale division, at one main scale division equals to x. So x minus sorry, one division on the Vernier scale, that is n minus 1 x divided by n. By LCM this we get xn, after opening the bracket, xn minus minus plus, and that is x. So xn can be cancelled out. So now is x by n. So formula is x by n. Least count of the Vernier scale is x by n. So one main scale divisions divided by number of division of Vernier. So easily we can type this formula as a least count is one main scale divisions divided by number of divisions of Vernier. Vernier, we have to know that by 10 divisions in the Vernier scale. So x by n, and then also the calculation formula, observed reading equals to main scale reading plus Vernier scale reading. Vernier reading. Sorry. So this is the Vernier calipers. So first we also have to again revax that Vernier have a 10 divisions main scales. In main scales, 10 division of the Vernier scales coincide with the 9 division on the main scale. So the least count is x by n, and observed reading by the Vernier scale of object is main scale reading plus Vernier reading. Now we have to discuss about zero error. Zero error is both in the screw gauge and Vernier also. So zero error is a positive zero error and negative zero error. What is the mean of the positive zero error? If the main scale 0 is main scale 0 and the Vernier scale 0. If the Vernier scale 0, Vernier 0, shortly we have to take the Vernier 0 is on right side of main scale 0, main scale 0. If the Vernier 0 is the right side on the main scale 0, then positive 0 error. Negative, left side. If the Vernier 0 is present on the left side of the main scale, then it is a negative 0 error. Now we have to go through the screw gauge. So rub these Vernier calipers. Screw gauge is also instruments. Precision measuring tools used to measure the diameter of the thin wires. So screw gauge drawing is like this. It is a simplified drawing. This is screw gauge, and this is the main scale of the screw gauge. So Vernier scale we have to know that main scale represents, and screw gauge also have a main scale, and this is in place of Vernier scale. Here is a circular scale, and this is the screw. To hold the objects, we place between the screw and the stud. This is the stud. If an object placed between the stud and the screw, then we have to precisely measures the length or diameters of the objects. Okay. Circular scale depend on the screw gauge, mainly 0 to 100 divisions. Or maybe 0 to 50 divisions. That means by rotations of 100 divisions. Rotations of 100 divisions of circular scale. Screw moves 1 millimeter. It is also called pitch. So if we turn the 100 divisions of the main circular scale, screw move. Like this example, we move the circular scale and screw moves. We move the circular scale and screw moves. Here the line is the graduated lines or the calibrated lines. We have to know that if we move the circular scale, screw moves. If we move the circular scale, screw moves. So if 100 divisions rotations, screw moves 1 millimeter, then the pitch is 1. Okay, so least count of the screw gauge here, pitch divided by total number of divisions of circular scale. Pitch, that is 1 millimeter, and total number of division 100. So 1 by 100, that is 0.01 millimeter. If we take a centimeter, 0.001 centimeter. It's clear. So in respect to the Vernier caliper also measured the smallest object diameters, thin wires, and screw gauge also helps to measure the diameters or the length of the thin wires. But their measurement techniques are different. Vernier calipers, vernier scale, coinciding factors. In screw gauge, there is a pitch and the total number of circular scale divisions. So now, if we take a difference of the vernier caliper and screw gauge, it is for vernier caliper, it is used to measure the length of a rod diameter and the sphere and the internal and the external diameter, external diameter of the hollow cylinder. And for the screw, it is precision measuring to use to measure the diameter of the thin wires. And the observed reading for the vernier and screw gauge is there. Observed reading for the vernier and screw gauge, both are the same, but the formula in the middle is a difference. So for the vernier, we know that observed reading is a main scale reading plus vernier reading, and for screw gauge, main scale reading plus circular scale reading. Let's take any numericals to clear your views. Suppose this is the main scale and this is a vernier scale. Okay, 12, 1, 2, and this is 0. First take the lines 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 10. 13. And the main scale, we know that again, main scale again 12 to 13, that is 10 divisions. Okay. So 10 division equals to 1 centimeter. 1 division equals to 1 by 10 centimeter, and that is 0.1 centimeter. Number of division of vernier, 10. Least count, again the formula least count is x by n. X stands for main scale divisions, and that is 0.1, and the number of division of the vernier scale, that is 10. So 0.01 centimeter. Now to take the measurement, we know that 12, that is a 12.1, that is a 12.2, and that's all. 12.2. Observed reading, (12.2) main scale reading. This is a main scale reading, and vernier scale reading is, vernier scale coincides with the 13 of the main scale, and for vernier scale this is a 1, 2, 3, 4, 5, 6, 7. So 7 mark coincide with the 13 divisions, but that is a 13 marks of the main scale. So 7 on vernier scale and the Vernier scale least count is 0.01. So 0.01 multiply 12.2 Vernier scale coinciding factors into least count. That is 12.2 plus 0.07. So our answer is 12.27 centimeter. So perfect or observed reading is 12.27 centimeter. Now we take an example of a screw gauge calculations. So it's clear. You can pause this video and correct your views. If we take a screw gauge like this short examples, and this is our circular heads, okay, and this is our main scale 0, 1, 2 something, and this is our circular head, and that is 1, 2, 3, 5, 1, 2, 3, 0, 1, 2, 3, 4, 5, 95, and that's all 1, 2, 3, 4, 5, and that is a 90 here, and that is a 100 division. We know that a 100 division on the main scale is circular scale. The number of divisions, on circular scale equals to 100. Least count equals to least count. Least count here is pitch divided by total number of division of the circular scale. So pitch of the screw is 1 millimeter. That is, again, if we go through this circular scale, then main scale move 1 millimeter. If we go through the circular scale, main scale move 1 millimeter. So pitch is 1 millimeter. So 1 divided by 100, because circular scale division 100, so that is a 0.01 millimeter. If we take a centimeter, 0.001 centimeter. Here main scale reading is 2 millimeter. 2 millimeter. Here main scale reading is 2 millimeter. Circular scale reading is P. What is P? P stands for the number of division that coincides with the main scales. Here the number of division is a 97, coincides with the main scale. P into least count. So in case of the Vernier scales coincides with the main scale, and that we can take and then multiplied with the least count. Here also P into LC, and that is a 97 into 0. If take a centimeter, 0.001, and that is 0.097 centimeter. So observed reading is here. Observed reading, main scale reading 2 millimeter plus 0.097. 2 millimeter means, if it is a centimeter, if it is a millimeter, then the calculation is wrong. So we have to first calculate this 2 millimeter as a millimeter as a centimeter. That is 0.2 centimeter plus 0.00097. So answer is 0.297. Okay. So Vernier caliper and the screw gauge is simple calculation is completed. Vernier scales, main Vernier scale reading and the main scale reading Vernier scale coincides factor for a screw gauge. Circular scale and the main scale is the main factor. Circular scale rotates and the main scale calibrated is the main factor. So both have a least count, and the least count can be multiplied with the number of coinciding factors. So then we have to correct the views of observed reading. And if take a volume we know that substance occupies space is called volume. If an unknown mass of a substance, to calculate the volume, we use the measuring cylinder. First we take a measuring cylinder also is this way, like a test tube. So measuring cylinder is also calibrated. 1 2 6 2 SS, like this calibrated. So 1 2 3 and that values. If first of all we take some amount of the liquids present in the measuring cylinder, and calculate the volume of this liquid volume. If it is a 10 ml, and then unknown mass of a substance is put on this measuring cylinder by a thread, fine thread. If the level is goes up to the something, then we again calculate the observed reading, and that is if it is a 12 ml. So volume of this substance is 12 minus 10. It is very easy, 2 ml. So volume of the substance is 2 ml. Then we have to use the calculation basis density equals to mass by volume. So if calculation of the mass, we first multiply density with the volume. So density of the substance, if it is given in the numericals and the volume calculation is here, so easily calculates the density and volumes. Okay, today videos is now ends, and if you like my videos, please subscribe and like. Thank you for watching.